Good evening, morning, or afternoon, whenever you're watching this. We are in geometry tangent ratios. Okay, so here's what I want you to do. I want you to pull out a separate piece of paper, a notebook, wherever you're writing down your notes. Go ahead and write down these vocabulary words are the ones that you need to know for this lesson. Okay, so vocabulary words: tangent, opposite, adjacent, and hypotenuse. All right, so tangent is the value received when the length of the side opposite to the angle theta is divided by the length of the side adjacent to angle theta. Again, that means nothing to you right now, but we're going to get into what that means in a bit. For now, just write it down. Make sure it's the first thing in your notes. When I say the word, in this case, this was this one. When I say the word opposite here, you're gonna hear me say the word opposite and adjacent frequently throughout this lesson, and I need you to know what that means. In this context, we're talking about tangent ratios. We're actually talking about a right triangle, right? We're talking about right triangles, and we're talking about specific angles, and we need to find a way to talk about the sides of a triangle in a specific way. So the words opposite and adjacent actually tell us which side of the triangle we're supposed to be using. For example, if I say, let me draw a right triangle down here, right? Say this is a right triangle. It's a CBA, right? And I'm focused on either angle A or angle B. Let's focus on angle A. If I want to know the opposite, that means the side of that's supposed to say triangle, forgive me, the triangle that is diagonal to the angle you're focused on. So let's say this is like, I don't know, 20 and this is 40, right? If I'm focused on angle A, the opposite of angle A would be directly diagonal to it. The opposite would be 20, right? So opposite of angle A is equal to 20. If I wanted to know adjacent instead, right? Adjacent means the side of the triangle that is attached to the angle you're focused on, but is not the hypotenuse. What that means is the triangle is going to have three sides. There's going to be one side that's the largest. It's usually the one that's diagonal because remember, this is a right triangle, which means there's going to be one side that's diagonal. That's usually the largest side, right? We don't want to use this. We're going to use this next week when we do sine and cosine. But for now, we're doing tangent. We don't actually need the hypotenuse, but you do need to know what it is and where to find it because that's not what you're going to use. When I say adjacent of angle A, what I really mean is the one that's right next to it, this one. It's attached to it, but it's not the largest one that's attached to it because the 60 is attached to the A, and the 40 is also attached to the A in terms of the lines. We're going to use 40, okay? Now, we're going to use the same triangle, right? We're going to do that. But this time, we're going to focus on B, right? We're going to focus on B. What if I wanted to know the opposite of angle B instead? Well, opposite of B is different because B is over here. The opposite would actually be 40 because 40 is the line that's diagonal to measure angle B. However, when we're talking about adjacent of measure angle B, right, it's the one that's right next to it that's not the largest side. Remember, there's two lines that connect to measure angle B. That's the line that has 60 on it, and that's the line that has 20 on it. We want the smaller one, right? So if you notice, the A and the B are kind of opposites of each other, right? This is important because everything that we're doing is going to revolve around that simple fact, the fact that they're kind of the reverse of each other, right? And then the last vocabulary word, of course, right? Hypotenuse. Hypotenuse is just the largest side and is the one opposite to a 90-degree angle, right? Okay. By the way, if you're confused as to what's what, or like, how do I know which one I should avoid using, right? Locate the right locate the right angle first, and then look at the line that's opposite to that. That's going to be your hypotenuse, and you can just cross that out. Like if I were to just, right, cross out the 60 from the beginning. And let's undo that because that was terrible and it's bothering me. Okay, there, that's better. Um, yeah, so we don't even need the 60. If you notice, we're not using the 60 at all. And we're only using it in terms of like helping us figure out what's adjacent and what isn't, right? Okay, so that's kind of the introduction to what you're doing. Let's actually get into what you're doing. All right, so this is the first time. I'm going to go over 3 types of problems in this video, right? The first of the types of problems is how to find the tangent of a right triangle and what I expect you to do when we're doing this. Now, keep in mind that Geometry B is a class that's a little harder than you're used to. There's a lot of trigonometric principles that we're going to go over um, that just kind of overlap with Geometry B. If you feel lost at any point, feel free to email me or reach out to me. Don't just not say anything, all right? Okay, so moving on. Let's start with what the problem is, right? The problem here says, find the tangent of each specified angle. Write each ratio as a fraction and as a decimal to the second decimal point. Now, this word ratio, what you need to know about the word, you're going to see it a lot. Ratio just means fraction. I mean, it has a different definition, but for your purposes, you can, every time you see a ratio, every time they ask you for a ratio form, what they're really asking is that you put your answer in the form of a fraction. Okay, that's all it really means for our purposes, anyways. Um, a decimal is just what happens if you actually divide a fraction out, right? Okay, so here I'm gonna call your attention to this triangle, right? It looks kind of like the one I drew in the last one. We have CBA again, and then we have 18, 24 this time, and we have 30. Now, what I have here, and this is something you should really write down if you haven't already, tangent is what you're looking for. And this is technically the formula for it. It's really just called a tangent ratio. Tangent, which is what we're looking for, is equal to opposite over adjacent. Okay, that's the shorthand version of it, right? Sometimes you'll see something like this. You'll see me shorthand this and do it this way, right? That's basically saying is tan, and whatever letter is next to tan is it's the angle that I want you to focus on. I want to be very specific about that. Every problem is going to have you focus on a specific angle, and it's never going to be the right triangle or the right angle. It's never going to be C. It's always going to be either tan A or tan B. All right. So let's start looking at the first example right here. It's all typed out. Tan of A. So we're going to focus on A. So I'm going to go ahead, and the first thing I'm going to do when I draw my triangle, I'm going to draw this triangle. If it's not already drawn for me, I'm going to circle A because that's what I'm focused on. I need a visual here, right? Tan of A equals the numerator, which is going to be the number on top of this fraction. This whole thing is a fraction. The length of the leg opposite to angle A. Okay, so we want the length of the leg. The leg is just referring to the sides of the triangle, right? We want the one that's diagonal. You see how I drew that from that A, that angle A, I drew a diagonal line to the 18 because that's the opposite to it. So that's why 18 is the leg that's opposite to angle A. On the bottom of that fraction, the denominator, right, it says it's the length of the leg adjacent to angle A. Now there's that word again, adjacent. Now remember, according to the definition, adjacent just means that it's a line that's connected to the angle that we're focused on. In this case, is angle A. So we want a line that's connected to it. That's either this line or this line, right? But we don't want the hypotenuse. Under no circumstances can we use the hypotenuse this week, which means that the hypotenuse is the largest side, which means 30. It can't be 30, which means it's going to be 24, which is why over here, right, I have a fraction right here. 18 divided by 24. That's how I figured it out. 18 was diagonal to A, and 24 was adjacent to it, but not the hypotenuse. Okay, so what do I do now? I reduced it in the next step. This next step is just to reduce my fraction, right? You might be thinking, okay, what does reducing mean? Well, in case you don't know, reducing or simplifying just means that 18 or 24 is a big fraction. Well, kind of. I want to make it as small as possible. I have to think what's the greatest common factor, or what number multiplies to get me 18 and 24, right? What's the biggest number I can divide the top by as well as the bottom by? Remember, I have to divide both the top and the bottom by the same number. In this case, if I divide them both by, I don't know, 6, right? 18 divided by 6 gives me 3, and 24 divided by 6 gives me 4. I'm not changing the value. All I'm doing is making it smaller so I have smaller numbers. This is technically my tangent ratio. This is technically my answer, right? However, the instructions say that they want it as a fraction form. Okay, cool. That's my fraction. What about as a denominator, right? They want the decimal to, they want the decimal to be to the second decimal point if possible. If I were to take 3, which is my numerator, now we're to divide it by 4. So in a calculator, I put 3 divided by 4. I end up getting 0.75, and it actually stops right there. So there's no need to round it. But if it kept going on, let's say there was like, let's pretend there was a 2, a 3, and it went on forever, I would start at the second decimal point, right? 1, 2. Then I would look to the next number, and if the next number is a 4 or lower, it reduces to 0. If it's a 5 or higher, I'm gonna add 1 to this number, right? So what do I mean by that? Let's pretend that this is a 2. They became a 0, right? 0, and then I don't have to write the 0 at that point. I can even just ignore it. I can just leave it at 0.75. But instead of a 2, let's say it was like a 7 or something, right? That means that this forces the 5 to go up by 1, and that's what it means to round, right? We're just looking at the number next to it, right? In this case, that wasn't the case. We just left it at 0.75 or whatever your calculator told you, right? Okay, cool. So now I know what the tangent A is. I have my ratio and I have my denominator. What's next? I keep saying denominator, sorry. I have my decimal. I mean decimal. All right. So tangent B, right? Now that I did all this stuff, right? What am I gonna do? Well, I need to do the exact same thing, but with instead of focusing on angle A, I'm gonna focus on angle B. All right. So everything is from the point of view of angle B now. And angle B, notice it's the same formula. It's still opposite over adjacent, right? However, the opposite of angle B, if we draw our diagonal, is actually 24, and adjacent is actually 18. They're reversed, right? It's the reverse. And if there's a reverse, we can use the same simplification. It's still going to be 4 over 3, right? Because I can still divide both of them by 6, right? By the way, when you simplify, um, you can just put it in the calculator as well. You can just, I would accept if you just left the 24 over 18 as your fraction. I would prefer that you simplify, but if you're having a real hard time with it, don't get hung up on it. Right? Like if you're just like, I don't understand what simplifying means, get help from me. But in the meantime, you could always just leave it as 24 over 18 and then just put it in the calculator and it should tell you the decimal. If we put 24 into the calculator and we divide it by 18, or if we put the simplified 4 divided by 3, you should get the same answer every single time. The calculator would spit out 1.33, and I believe it keeps going on forever. And the other one is 1.33. This is what we call an irrational number. Right? I'm not going to get into too many details about what that is because there's just not enough time in the 5 weeks. But know that an irrational number just means that it goes on forever. This thing technically goes on like this, and it just repeats. Obviously, the calculator runs out of space, but you should know it goes on forever. So again, we want the decimal to the second decimal point. The second decimal point is the one that we're focused on. It looks to the right. A 3 is 4 or less. So the rest of them become zeros, and I'm left with 1.33. Okay. All right. So this is my answer for tangent B is 4/3 or 1.33. For tangent A, it's 3/4 or 0.75. You see that they're not the same thing, and you need to be very careful with that. You also need to be aware that because they can switch places, you just need to be very aware of where it is. If you notice, I used a circle for A and I used a square for B. That's how I like to show it visually. You can use whatever system you want. Just understand that you know which angle you're focused on at what point. Okay. It's always useful to draw out the triangle. I would strongly recommend that you draw out this triangle on your work especially when you're showing your work. I wanted to see the triangle. And then if you can do these like little lines that show opposite, that's how you're showing your work, okay? Okay, good. This is how you do the first problem. Yep, we're gonna move on to the second problem. Second type of problem is a little more mathematical, right? So how to find the side length using a tangent, right? The real world application to this is how do I find the side of something without measuring it if I know the angle um, and the length that something is away from it. The best example for this is a ladder on the side of a house, right? Let's look at the example, right? We're up here. In order to meet safety guidelines, a roof contractor determines that she must place the base of her ladder 6 feet away from the house, making an angle of 76 degrees with the ground. So the nearest foot, how far above the ground is the roof? All right. So here's the thing about these angles, right? We're assuming that the side of the house meets the ground perfectly at a 90-degree angle, as most house sides of most houses do, right? That's one thing we're assuming, right? We're also saying that there's safety guidelines, which means every one of these roof contractors knows that one of the safest degrees you can use is apparently 76 degrees, right? Because they want that to 76 degrees if you're placing the ladder 6 feet away. And you would place the ladder 6 feet away from the house. You're making an angle. This is shown in this triangle that I drew on the side. The interpretation is just me going through my thought process of what I would do if I was doing this problem, right? Okay, so the problem is saying that you're laying a ladder against the side of a house, which makes it to the shape of the right triangle with 90 degrees. Forgive all the spelling mistakes. Draw the shape and and label what you know so we can get an idea of what you're looking for. Then start the problem with a tangent ratio. Okay, so this is just saying like I need to draw this triangle out, right? If you notice, angle A is the one that has the angle, right? Because when I lean the ladder, right, against the side of the house, the ladder is going to make a 76-degree angle with the ground. And the ladder is also 6 feet away from the house. The house starts in angle B and C. BC is what I'm looking for. I want to know how tall it is, right? How tall the house is, the side of the house that I'm going to climb is. Okay, so let's get started. We always want to start in step one with our formula, right? We start with tan of A because, by the way, if you're confused as to where to start in this problem, I'm starting in tan of A because A is the only angle that I know in this triangle that's not 90 degrees. If I knew what angle C is, which there is a way to find out, which I'm not going to go over just yet because we don't need to know it. But if I knew what angle C was, I could use tan of C, and that would change the way the problem looks. But I could, in theory, use C to figure this out as well. But in this case, we don't know what C is. We do, however, know what A is. So we're going to use A instead. So tan of A is the angle we're focused on. I circled A. Cool. Is equal to opposite over adjacent of whatever angle A is. Okay, there's a problem, right? Because if I want to know what the opposite is of this, I actually don't know what it is. There's a bunch of question marks there. That's what I'm trying to figure out. So I'm looking for BC, right? That's what I'm looking for. I'm looking for the height or the length or whatever of BC. Then I want to know the adjacent. Well, adjacent is the one that's right next to it. And I don't know what the hypotenuse is. But that's fine because I actually don't need it for this problem. What I need is the adjacent, which is, of course, 6 feet. With this information, I'm going to move on to step 2, and I'm going to substitute, right? I'm going to substitute what I know, and I'm going to replace everything. So tan of A is just 76 degrees. I already have my answer, technically. But that's not what I'm looking for. I know that the angle is 76. I'm looking for the height. I'm looking for BC. So I'm going to write BC divided by, well, 6 because my adjacent is 6. All right. Hopefully you're with me so far. We're going to move on to step 3. Now we actually have to use math to solve this, right? What we have here is we have an angle 76 is equal to a fraction BC over 6. We have to get rid of that fraction. And in order for us to get rid of that fraction, we're going to have to use some algebra here. We're going to use inverse operations. In other words, BC is being divided by 6. And in order to get rid of the 6, because we want BC to be by itself, we have to do the opposite of what it's currently doing. It's currently dividing, which means that we're going to have to do the opposite of division, which is multiplication. We're going to have to multiply both sides of the equation, of the equal sign, by 6. That's why I'm multiplying it by 6 over 1. By the way, 6 over 1 is just 6, because 6 divided by 1 is just 6. I'm only doing this because it's a fraction and they're going to cancel out and it's easier to see it visually, right? So I'm going to do inverse operations, right? Multiply both sides by 6, and what ends up happening is we have a fraction on this side, right? We have a fraction. We have 6 on top of the fraction, and we have 6 on the bottom. If we have the same number on the top and on the bottom of a fraction, they cancel out, right? And I'm left with BC over 1. Anything divided by 1 is just itself. So I essentially have BC by itself, which is good. What's not good is on the left side of the equation, I have 6 over 1 times 76 degrees, and I have to solve that. We're going to move on to step 4 to solve that. For step 4, we're going to use a calculator to find out what tan 76 approximately is, and then we're going to multiply it by 6, right? So you might be wondering, what does that mean? Calculator, I don't own a calculator. Well, okay, cool. For starters, there's a calculator on your phone, and most people have phones. If you're using an Android phone, there is a tan function when you put it to the side or anything like that. If you're using an Apple cell phone, they're a little weird, and you have to put the number first, and then you have to find the symbol. I'll go more into that later, but for now, there's a Desmos link on this Google Classroom. All right, and there's a video on how to actually put this to find out what tan is, to find out what cosine sine is, inverse tan, all of it. There's a video right next to the link, right? It's under the material section. It's under its own section. Go ahead and check that out, right? But pretty much what we're doing is we're putting tan in a calculator. Depending on your calculator, the calculator might have parentheses in there. 76, we have to find the closed parentheses, and it'll give us approximately 4.01, and it kind of goes on after that. This is if you're using an Android, it'll look like this. If you're using an iPhone, you have to type in 76, and then you're going to look for the symbol. There's going to be a button. You have to turn your phone to the side, by the way. 76, and then you're going to look for the symbol that says just tan. You're going to press it, and it'll just give you a number that resembles this 4.1, and it'll have a bunch of other stuff. If you're using Desmos, right, you click the tan button, right, on the calculator, and then it'll automatically populate like this, and you just type 76, and before you even put the parentheses, it'll have an answer for you. It'll say 4.1, and it'll keep going, right? I just abbreviated to 4.01 because, again, that's just a good habit to abbreviate it to the second decimal point. Okay, so now I replace 76, tan 76, right? Because all this is really what it is. Tan 76 tan 76. Tan 76 becomes 4.01, and I'm going to multiply it by 6 because remember I'm multiplying that by 6 to give me BC. I end up with something like 24.06, and I want to round this answer to the nearest whole number because we're talking about degrees here. And the 4 looks to the 0, and since the 0 is less than 4, they all become zeros. I'm just going to have 24. BC is the nearest foot is 24 feet. This ladder, the side of the house is 24 feet, right? And that was the answer that I was looking for. So hopefully that made a little sense. If you have to rewatch this, go ahead and rewatch this. Contact me again if you're having trouble with this. It can be a little confusing at first, but just try it out. The best way to do this is just try it out first. You get stuck, come back, watch the steps, retry the steps, right? You'll get used to it. Okay, so let's move on to the third and final problem, all right? Okay, this is a third type of problem that you're gonna run into, right? This is finding the measure of a missing angle using inverse tan. So this problem is saying, what if I have both of the legs of the triangle? I just don't know what angle I have. I'm looking for the actual angle. In the previous problem, you were given the angle in the problem. They knew that the ladder and the floor made an angle of 76 degrees. But what if you're like, this is the real world. I don't know what angle I'm making here. I do, however, know that the house or whatever is 19 feet and the ladder is for some reason 36 feet away, right? What angle did I just form on the ground, right? Well, you have to kind of go backwards. And this is where it gets a little tricky. All right. Instructions. Find the measure of the nearest indicated angle. Round to the nearest degree. In this case, the problem is asking, what is measure angle A? Right? We're going to approach this the same way that we approached the last problem. Start with the formula. Start with the tangent ratio. Tan of A, because they're asking for A, so I want tan of A, is equal to opposite over adjacent. Tan of A and the opposite of A, right? I may not know what the angle is, but I can still see that the opposite side is 19. So opposite is 19. And I know that adjacent is the only other number here, 36. Right? I don't have an hypotenuse and I don't need it, frankly. So here, my adjacent is 36. Now I'm going to substitute the information that we're given. All right, we're looking for angle A. So far, we've done step 1. We've done step 2. Now we can move on to step 3. This is the hard part. Rearrange the formula into inverse ratio so that we can reverse our problem. I keep saying inverse ratio. You might be wondering, what is that? Inverse ratio, right, is just this. An inverse ratio means if I have tan of A, inverse is 1 over tan of A. But instead of writing a fraction the entire time, they abbreviate it using this. And this is the symbol that you're going to see on the calculator, by the way. You're going to have to look for tan with a little -1 on top of it. All right. That's why I have to rearrange it. So tan of -1 in parentheses, then you're going to put the fraction that you had from here. Like if you notice, this is the fraction. Tan of -1 in parentheses, 19 over 36, close parentheses, equals what I'm looking for. I'm looking for measure angle A. This is called rearranging the formula, right? The A and the 19 over 36 switch places, really, is what happened, right? Because we're trying to go in reverse. We have essentially our final answer. We're trying to figure out what numbers gave us our final answer, if that makes any sense. We're going backwards, if you will. Okay, so what do I do? Once I rearrange things, once I'm in step 3, what do I do now? Well, you're gonna just use your calculator. When I was learning this, I had to use a chart of inverse things and I had to look it up and it was a pain. I am not gonna make you do that. Instead, however, I am gonna demand that you learn how to use the calculator to find this because the calculator, believe it or not, your ability to use the calculator is going to be crucial in weeks 2 and weeks 3. We're in week 1. So we're going to need some practice with it now. So by the time you get to week 3, you're pretty good at it, and we're going to have intensely more complicated formulas being put into the calculator. But you need to learn how to use the calculator first, which is why I'm asking that you put tan of -1, parentheses 19/36 into the calculator, and you have to understand what that looks like if depending on the calculator you're using. Again, if you're using an Android, right, you're gonna look for the additional options. Usually there's like an arrow, you have to put it to the side. I don't know, you're gonna do something with it. And you're gonna have to look for the symbol tan -1. Press it, and when you press it, it'll say tan -1 on your screen, and it'll have a parentheses already there for you, usually. Right? If it doesn't have one, put a parentheses on there. There'll be parentheses buttons on your calculator at that point. Then you're gonna put 19, and you're gonna put the division symbol. Then you're gonna put 36, and then you're gonna close it, and then you're gonna put equals, and it'll give you an answer. It'll give you approximately 28.82409638. I stopped trying out there, but it'll give you a really big number, right? This is if you're using an Android phone, right? I'm assuming you're going to use the phone. If you're using an Apple, good luck, because that calculator is really annoying to use. You're gonna have to move it to the side, right? You're gonna have to put 19 divided by 36, and for some reason it won't show you the whole thing. It'll delete everything as soon as you write it. So you're 19 divided by 36. It'll give you a number. I don't know what number it is because I don't own an Apple. I just know that this is how it works on them. An Apple phone, I meant to say. But it'll give you a number. Whatever number it'll give you, then you're gonna press tan -1, and then it should give you the same number, 8.24, whatever, right? This is if you're using an Apple calculator, and good luck if you're doing that. If you're using the link that I have in this class, right, the one for the Desmos calculator, right, you're gonna wanna go to function. There's gonna be again, look at the video and go to the end of the video that I have on that. That'll tell you specifically how to find the function, but you're gonna have to press the function button. Then you'll have the option to press tan -1. Then you're gonna fill in the 19 divided by 36, and then at that point, make sure to click outside of it so that you can put the outside. Because if you don't click outside of it, it's gonna put a parentheses on the 36. That's not what you want. Click outside of it, and it'll have like a faded close parentheses. Make sure to actually close the parentheses, and then it'll have the answer for you, which again will be the same thing, 8.24. These are just different calculators that you might be using. This is how I got this. This is how I got step 4, right? I don't want all those decimals. You're gonna have to round them, right? Measure angle A, your actual answer is to round to the nearest whole number. That's 28. You look at the number next to it, right? 28.824. So should that be one above? Yeah, I should probably be 29. Let me double check that because that doesn't look right. Maybe I wrote the wrong number. Let's see. Right. I did write the wrong number. 28 is the answer, but there. It was supposed to be a 27 point. Yeah, sorry about that. All of these are 7s. Right? You should have gotten 27.824 or whatever it is. Right? The 7 looks to the 8. The 8 is bigger than a 5. That means that the 7 becomes an 8. 28 degrees. The answer is measure angle A is 28 degrees. Okay. One last thing I want to show you. Yeah, you guys thought it was over. No, it's not. All right. So what about tangent B? We know, if you notice now, my 28 is there. But this time I'm focused on B. What if I wanted to figure out what B was? Well, there's a shortcut to figure out what B is, but I'm not going to tell you what the shortcut is until I show you how we derived this really fast. Tan B, I did the exact same thing, except this time I have 36 as my opposite. I have 19 as my adjacent. It's reversed, right? I do the whole tangent -1 thing, but then I put 36 on top and 19 on the bottom. And I end up getting this number, 62.17. Don't worry, I checked. This one's correct. 62.17590,362, right? And then I round it off to 62, which means that this is 62 degrees. Okay, this is how I know I did it right. This is how I know that everything is correct. Because, so if you took my last class, you should know that a triangle is 180 degrees. The total amount of degrees possible in a triangle is 180 degrees. This means 90, right? We found out that through tangent B, we found out that this is 62 and this is 28. If we add 62 plus 28 plus 90, we end up getting 180 degrees, which means that this not only works, but I did all my tangent A and tangent B correctly. Also, this is technically a shortcut that I just showed you, because if I wanted to figure out the missing side for B and I didn't feel like using tan B, I could, in theory, just take 180, subtract 28, subtract 90, and I would get 62, and that would be the correct answer. Shortcut that you're going to use in week, possibly in week 2, next week, definitely in week 3. But we'll get into this potential shortcut later. All right. Last thing, if you have any problems, please email me at If you have problems, please send me an email at dpalacios@laedcorps.org. And yeah, send me a message there, leave a private comment on your work, and good luck, guys.